All right, pre-calc brainiacs. Gonna go ahead and work on section A.2. This one's called Polynomials and Factoring. Everybody's favorite. Factoring. Bad news, everyone. You gotta be good at factoring. You don't have a choice. You have to be good at factoring. It's gonna come up, oh boy, so much this year. You must be good at factoring. So if factoring is a stumbling block, please do something about it now. Don't wait until you're getting that ticket to put that seatbelt on, okay? Let's go ahead and get good at factoring now. We need a GIT, GUD, if you know what I mean. Okay, we need to get good. Anyway, my wife is making a stupid face at me. Anyway, we are going to start with something very, very simple. It has nothing to do with factoring. It is just adding and subtracting polynomials. This is just going to involve us basically combining like terms, especially when it's just a plus sign. It's really, really easy. Let's see what we have. Like terms, I see a cubic here and a cubic here. Two of them plus, I know it's not written, but there's a 1 there. Two of them plus one more is going to give me 3x to the thirds. Now we'll look to our x squareds. -3 and +2. -3 plus 2 is -1. So we say -1x squared. I'm not going to write the 1. It's a waste of time. You don't really need to write it. You can if you want. It's not wrong. It just won't be on my test. We have a 4x and a -5x. So 4 minus 5 is once again -1. So -x. And lastly, -1 and 3 come together to give us a +2. Boom, that's it, done. Okay, don't overthink it, let it be easy, and then move on. Now part B, that's the place where if students are going to mess it up, it's going to be with a question like part B. And it's because of the pesky minus sign right there in the middle. You have to remember that that minus sign belongs to the entire set of parentheses, which means you need to distribute it, so to speak, to all of these parts, like that. So what I'm going to do is I'm going to drop my parentheses and write down all my terms after I have distributed this negative sign. So the first one's just going to be 4x squared plus 3x minus 4. Now, minus 2x to the third minus x squared minus -x. Minus negative always means plus. Plus x minus 2. And then we're just going to do what we did in example A, combine like terms. But we do need our answer to be written in standard form, which means the term with the largest exponent has to be written first. So we go through here, hunting down largest exponent. There it is, right there. And remember, the symbol in front of a term belongs to that term. So our -2x to the third gets written first. -2x to the third. The next highest exponent needs to come first, so this would be our x squared. So we tracked on all of our x squareds. There's one here, 4x squared, and a -1x squared. Since they're on the same side of the equal sign, you don't do any opposites. You wouldn't add this. That doesn't make any sense. You just pretend that you can't see the junk in between them, and you go, oh, 4x squared minus x squared, meaning -1, is going to give us 3x squared. Next, we come to our x's. 3x plus x plus 1x. So 3x plus 1x is +4x. And our constants, -4 minus 2, -6. And that one's finished too. So for the rest of the lesson, we're going to be focusing on factoring. All factoring begins exactly the same way, hunting for common factors, looking for GCFs. Does everything have a GCF? Well, no, but it should be the first thing you do is look for a GCF. And, since we're under this heading, of course, these are going to have a GCF. In this first one, so we look at all three terms and we ask ourselves, do all of the numbers have something in common? And the answer is yes, they're all even. which means they could all be divided by 2. As factoring is a type of division, so we're going to pull that 2 to the front, and let's see if can it give up anything else. Well, this one has 3 x's, this one has 2, and this one has 1. That means that if I had to steal x's from all of them, the most I could take is 1, because this one can't give up more than 1. So I can't take more than 1. The term's not allowed to give me an IOU for an x. Okay, so I can take an x from all 3 of them. And remember, like I said, factoring is a type of division. So 2 divided by 2 is 1. X to the third divided by x just leaves me x squared. I stole one of its x's. 2 divided by 2 again is 1. X squared divided by x is, well, just x, because again, I stole one of its x's. And lastly, negative 6 divided by 2 is negative 3. I took its x, like that. Now that you've pulled your GCF, this is where you would try to figure out if this quadratic factors via Lizzy method or any other form of factoring that you like. Let's check. 2 numbers that multiply to negative 3 that add to 1. Okay, well, the only way that you can multiply 2 numbers to negative 3 is 1 and negative 3, which adds to negative 2, no. And negative 1 and positive 3, which adds to positive 2, no. Oh, finished. There you go. Now this one, okay, does it have extra variables? Yes. Does it need to be scary? No, it's not a big deal. If you approach it piece by piece like I did in the last one, it won't be a big deal. So let's look to our numbers. 4 and 8. They can both be divided by 4. Now let's look to our x's. This one has 3, this one has 2. I can't take more x's than a term has, but I could take all of them. This one has an x squared, and that one I could take an x squared from it. So x squared is part of that GCF. Now we look to the y's. This one only has 1. That means this term can't give me more than 1. And since this has y's in it also, I can take that 1 y away. And we see what we get. Well, 4 divided by 4 is 1. There was an x to the third here, but I took 2 of those x's out. There was a y here, but I removed it. That's all that's left from that term. Minus 8 divided by 4 is 2. I removed both of those x's, and I took one of these 2 y's, leaving behind a single y. And that one's finished now as well. There it is. All right. The difference of 2 squares. We just talked about the difference of 2 squares when we were discussing our complex conjugates. Because when you multiply 2 complex conjugates, the result is always the difference of 2 squares, which ends up turning everything into real numbers, but we did just discuss that. I'm going to write down the formula for the difference of 2 squares. Anytime you see something squared, a perfect square, minus, and it must be a minus, another perfect square, this can instantly factor to a pair of conjugates. A plus b times a minus b. You don't need to overthink it. So let's see what we got going on. First, always look for a GCF. No, okay, there's no GCF. There is no number that goes into both 25 and 36. This one has no x's to give up, so there's no GCF. But 25 is a perfect square, and so is x squared. There's the minus sign, and 36 is a perfect square. So we can jump directly to our 2 sets of parentheses and just realize what you have is square root of the front, square root of the back. One gets a plus, one gets a minus. The order that you put your 2 parentheses doesn't matter. So the square root of 25 is 5, and the square root of x squared is x. Like that. 5x and 5x. The square root of 36 is 6. And that's it. It's done. Ta-da! So we're looking at this next example and you're thinking, well, it definitely doesn't look like that, does it? And in fact, it's got a plus sign. Must not factor by any kind of special case because this is a special case. And I go up, 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 up. Be careful. Because this leading coefficient is negative. And I like to teach my students that every time your leading coefficient is negative, you have a negative GCF. And sometimes that GCF is just -1. And even if that's the case, I want you to factor it out as a GCF. As it turns out, this one has more of a GCF than just -1. But we do see, hopefully, that the GCF does involve -1. So we have a GCF of negative, check that out, 45 and 5, those can both be divided by 5. And then look at these two terms. That one has an x to the third and that was an x. They could both give up an x. So we do have a GCF of -5x. And look what happens when you divide by -5x. -45 divided by -5 is 9, a perfect square. And stealing one of these three x's leaves behind x squared, a perfect square. 5 divided by -5 is -1. There's that minus sign. And x divided by x is not 0, folks, 1. It's division. So this is a perfect square minus a perfect square. Yes, 1 is a perfect square. Its square root is 1. So do not lose your GCF. That's mistake number 1 that I see often. And realize that factoring out a GCF is a form of division. 5x divided by -5x is not 0. It's -1. Square root of 9x squared is 3x. Square root of 1 is 1. And that's all she wrote for that one. Okay. That's all there is to it. Scrolling, so to speak, really sliding. Here we have a trinomial, means 3 terms. Leading coefficient is 1. It's just x squared minus 8x minus 48. This is just good old algebra 1, straight up and down, just factoring a quadratic. And since our a value is 1, we could jump straight to the two numbers that multiply to just c, because, well, a is 1, -48. And we need those same two numbers to add to our b value, which is -8. And yeah, there are two numbers that multiply to -8 that, that multiply to -48 that add to -8. Lots of numbers go into 48. Let's see, 1 goes in 48 times, 2 goes in 24 times, 3 goes in 16 times, 4 goes in 12 times. Wait a second. The distance between 4 and 12 is 8. Boom, there it is. So we're multiplying two numbers to get a negative, which means one is positive and one is negative. So my options are 4 and -12, or -4 +12. Since it's to add to a negative, we're going to have to say 4 and -12. So our quadratic factors into x plus 4 times x minus 12. And that's it, because there was no GCF at the very beginning. We knew that because there was no number in front of x squared, and because this term didn't have an x to give up. That's it. Simple. Finished. Now, we've already seen this in class, but what happens when you do have an a value that is not a simple 1? Factoring trinomial leading coefficient is not 1. First and foremost, you would always look for a GCF. They don't all have x's, and 3 and 4 have nothing in common other than a 1, which never counts, so no GCF. So for this one, this is the kind of question that I would be using the Lizzy method for. And for the Lizzy method, what I do is I say, okay, I need to figure out two numbers that will multiply to a times c, which is 3 times 4, or 12. I need those two numbers to add to my b value, which is -8. Are there two numbers that multiply to positive 12 and add to negative 8? There sure is. Otherwise, this would be a horrible example for my notes. It is negative 2 and negative 6. So this is how the Lizzy method works. You write your two sets of parentheses, and they both have an x sitting in front of them. These two numbers do go in these parentheses, but they belong on the top of a fraction bar. And underneath that fraction, your a value. Next, you reduce the fractions if they can. This one can't. This one can. 6 divided by 3 is 2. And the last step of the Lizzy method for factoring, because that is what we're doing, we're not solving, we're factoring, is to take any denominator that still exists and move it in front of the x that's in that set of parentheses. This quadratic will factor to 3x minus 2 times x minus 2. And there it is. Alrighty. Someone asked me about this recently. Were we going to factor by grouping? Well, of course we are. Just it only works if you have more than 3 terms. This one happens to have 4 terms. So yes, we can factor by grouping. This is a candidate for factor by grouping, excuse me. Not every polynomial that has 4 terms can be factored by grouping, but this one can, because once again, otherwise it would be bad notes. So how do we factor by grouping? What we do is we group the front 2 terms and group the last 2 terms. Notice how careful I was to capture this minus sign in this set of parentheses. If your middle sign, well, actually, it doesn't even matter if it's negative or not, always capture your middle sign in that second set of parentheses. The way factoring by grouping works is you now look at the first group only and you go, what is the GCF of this first group? What could I take from both 3x to the third and x squared? It's x squared. I can take x squared from both of those. And it leaves behind a 3x plus, and remember this is division, so x squared divided by x squared is 1. And now you look at the second set and you ask yourself, what could both of these give up? What is the GCF here? And remember what I just said a minute ago, the leading term here is negative. That means I have a negative GCF. And the negative number that both of these can be divided by is negative 2. Sometimes that GCF is just negative 1. Sometimes it is, and that happens. But this time it's negative 2. Dividing this by negative 2 gives me positive 3x, and dividing that by negative 2 gives me positive 1. Factoring by grouping only works if these two sets of parentheses are exactly the same. And if they're not exactly the same, either A, you messed up because you knew it had to work, or B, it just doesn't factor by grouping. So now what we do is, and this is the part that I see students always struggle with this idea. I need you to realize that these things are separated by multiplication. So if you can remember what I said some days ago, terms are separated by pluses and minuses. So when you see things separated by multiplication, you can treat them as one object. So I'd like you to look at the two objects I just boxed. And what I want you to realize is that these two objects do have something in common. Literally a GCF that could be removed from those two blue areas. So you look at this blue area, you look at this blue area, and you ask yourself, what do they have in common? Kind of like right here where I said, what did these two things have in common? And I moved to the front. Well, I think it's really obvious that this blue object and this blue object both have a 3x plus 1 in common. So we are now factoring out a 3x plus 1 as a GCF, which is division. And if I divide this term by 3x plus 1. All that's left over is x squared. And if we divide this term by 3x plus 1, all that's left over is minus 2. And there you go. Often I hear, Mr. M, where'd the other 3x plus 1 go? It didn't go anywhere. I factored it out from the two terms, just like here I factored an x squared from these two terms. Here I factored out a negative 2 from these two terms. Here I'm factoring out a 3x plus 1 from these two terms. It didn't go anywhere. It's still there. And finally, let's put it all together. Let's factor these polynomials. First of all, 4 terms. Okay, the only method that you have right now for factoring something that's 4 terms is grouping. That's your only method. However, before you start grouping, step A, number 1, should always be look for that GCF. And you know what? This one has one. I'm seeing 5, 10, 5, 10. Ooh, those are all divisible by 5. And look at this. Every term has an x in it. This one can only give up a single x, which means the most I can take is a single x. That means this will factor out and leave behind x to the third, because I took the 5 in one of the 4 x's. This is division. Negative 10 divided by 5 is negative 2. Leave behind x squared, because I took one of the x's. This is division. 5 divided by 5 is 1. X squared divided by x is just going to leave me a single x, because I took one of them. And lastly, negative 10 divided by 5 is negative 2 again, and I stole that x. So there you go. Awesome. We now have a 4-term polynomial, and factoring by grouping right now is our only option. Are there other options in the future? Yes. But for right now, grouping is the only one that we have. So we're going to do this and this, making sure to capture this middle symbol. I always make sure I capture the middle symbol. Please don't lose your 5x. It's part of your solution, and if you forget it, you will find your wrong answer on my test. You'll get partial credit for it, but come on, you know you want full credit. So we're going to just go ahead and write that 5x right now. Here's my red parentheses that I had up above. The first green group. The thing that these two terms have in common is x squared. I take x squared from x to the third, I get x. I take x squared from negative 2x squared, I get negative 2. There must be a GCF in order to factor by grouping. So you look at x and you look at negative 2 and you ask yourself, what is the only thing they have in common? It's a 1. And get skinny math. Pulling that 1 changes nothing. You look to this blue group and this blue group, and you pull a big old GCF. The 5x belongs on the front. These two blue groups can both give up an x minus 2. And when I steal x minus 2 from this term, it leaves me an x squared. And when I steal x minus 2 from this term, it leaves me a plus 1. Mr. M, a special case. No, it's not. This is a squared plus b squared, which will never, ever, ever factor. Don't get tricked by it. I'm just going to tell you, yes, I do make my wrong answers on my test by saying that this factors to x plus 1 times x minus 1. It doesn't. That's a wrong answer. A squared plus b squared never factors. Don't get caught. And our very last example, let's see what's up. Hey, that leading term is negative. So what does that tell you? It tells you you have a negative GCF. Let's look to our numbers. 3, 9, 12, 36. All those are divisible by 3. Now let's look to our x's. 4, 3, 2, 1. They could all give me 1. Dividing -3 by -3 gives me 1. I took one of the 4 x's. -9 divided by -3 is positive 3, and I took one of the 3 x's. Now 12 divided by -3 is -4, and I took one of those 2 x's. 36 divided by -3 is -12, and I took its x. For terms, grouping is our only option. Make sure you capture that symbol. Please don't lose the GCF. I hate when that happens to students. Actually, I'll write the other one in a second. Looking here, what do these two things have in common? They can both give me an x squared. When I pull the x squared, it'll leave me an x plus 3. Look here, begins with a negative number. That means I have a negative GCF. Both those can be divided by 4. So -4. -4x divided by -4 gives me positive x. And -12 divided by -4 gives me positive 3. They match, luckily, because if they didn't, then we goofed up because then you couldn't factor by grouping. Blue group. And blue group. -3x. Both blue groups could give up an x plus 3. When I pull x plus 3 from this blue group, I get x squared. And when I pull x plus 3 from this group, I get -4. And guess what? A squared minus b squared. That is a difference of 2 squares. It will factor to a set of conjugates. A plus b, meaning the square roots of those two things with a plus sign in between them, times a minus b, the square of the two things with a minus sign in between them. So this one finishes out, grab purple, as -3x, x plus 3, and then a pair of conjugates. Square root plus square root times square root minus square root. And now it's finished. Whew. That one was an exercise.